some examples. In case you missed it, then you might want to check that out. Yep. 167A is 27. Yes.
I just have a question on the 3
Okay. Which one?
167B.
Okay.
It says how many moles of each product will be produced. Do we use 18 moles of aluminum to find all of them?
Yes.
Then how would we find them? Or do we just not?
You use aluminum, 18. You use the 18 moles of aluminum
Okay.
in which to find the moles of both of them. You got to do 2 separate setups. You got to do one aluminum sulfate, and you got to do one to hydrogen. Okay. Anything else? The other 2 classes, I went through a couple examples, but if you want us to go right to what we need to do today, I can, but it's up to you. Any others?
I'm ready to just get into it.
Okay. Hopefully everybody else is too, but I want to give the opportunity because I think you can learn a lot if I've given answers out and you're not coming up with that answer, then at that point in time you say, Can you go ahead and show that one? Because I don't think I came up with that answer. I did something wrong. Okay? So there's 20 of you. That means all 20 of you got those answers right I just stated. Or you didn't do the work, so you wouldn't know. But are there any of those that you'd like to see that I've given answers for? Okay. All right. Need you to turn in your book to page 310. 310. Kevin, you're going to have to sit down and take notes on these when we start doing them. Okay? Can't be walking around when we're going through new stuff. So, Gavin, we're on page 310. Okay. The last one that you'll have to do, and I've added the 2 problems, 73 and 75, those are taking into account everything we did yesterday and kind of combining it all together in one problem. Okay? And so on these are called mass-to-mass problems. All right? Mass-to-mass just means you start with a mass of a reactant or product and you end with a mass. Okay? But you have to go through moles in which to accomplish that task. So we're going to look at sample problem E. Yes,
Can I
Gavin?
go get the restroom? I was
Yes.
in cooking class for like
Yep.
the last period, but I still have like the bit of churching on my hands.
Okay, so we're going to go ahead and look at this problem. Sn is 10 plus hydrofluoric acid. They call it hydrogen fluoride gas. You sure can. That's what we're doing this. SNF2 plus H2. Right? We have it balanced, and then what I'll do is use my equation to kind of know what I have and what I need to find. So it says how many grams of SNF2? We want to know how many grams of SNF2. And we're given 30 grams of HF. Okay. Now, if you remember, every problem that you do has to do a mole ratio. Okay? So if I have 30 grams of HF and I need to get over to grams of SNF2, what is the first step that we did yesterday in which to go from one substance to another within the reaction? So what do we need to do with that 30 grams? Make it to moles. Moles of HF. So what we would do the first step is we go 30 grams of HF, and then we'd go grams of HF to moles of HF. Okay? Before we put any numbers in there are some students that will mess this step up, and I'll explain why. Okay? There's two things that they'll do wrong on this step, and that's why I think if some people would have asked some questions on the day's assignment, those things would be clarified better. So I'm going to try to do it here. All right? So, grams of HF, sometimes students will take 2 HFs, and so they'll take 2 hydrogens and 2 fluorines, and they'll calculate it here. You don't do that. You have to just take whatever the formula is and calculate it. Okay, does that make sense? So we only use this 2 in HF when we do the mole comparison. That's the only time that we use those numbers in that equation is when we do the mole comparison within one step. Alright? So on this one, I just take the fluorine, take the hydrogen, add them together, and I get 20.01 grams. Sometimes students like to put 2 here, up here. It's just a molar mass. It's grams to 1 mole. So again, this 2 is only used one time. It's in the next step. So if your students get lost along the way and they're not sure what the next step is on these problems. So right now I'm here and I've got moles. I'm right there. If I would stop right now, that would be my answer. Okay? So I need to eventually get over to grams. So what's the next step?
Go to moles and SNF.
Yeah, I got to go to moles of S and F too. So I've got to do a mole ratio. So now down here I'll put, and this helps me because I just follow that unit and the label. So there's moles HF, and then I've got to come over to here to get this value next. So then moles of SNF2. So that's where my numbers come in, is when I do the mole comparison, mole ratio. So this becomes 2 and this is 1. Okay, so if I would stop right now, that would have been a problem that we would have did for today that would start out with 30 grams and ask for moles of SNF2. But we need to take it a step further to find grams of SNF2. So at that point, we don't have our answer yet. So the next step is to put moles of SNF2. And for some reason, students will put different units down here at times and symbols and not realize they have to always have the same unit and same symbol if they want to cancel them out. So we've got to make sure that we're consistent doing that. And then up above, I'll put grams of SNF2. So anytime we relate grams to moles, it's always 1 mole to whatever the weight is for SNF2. Okay? So that's what we would do. So 118.71 plus 38, which would be fluorine. 156.71. And then you get your answer. Okay? And they show all that work on page 311, just exactly like I have shown it. So if you want to look at that again, it's there, but 117.5 grams would be what your answer is. All right, so we'll have you guys practice one of these, and then at that point in time, we'll let you work. So you'll probably have a good amount of time to ask questions, to work. I'll come and peek over your guys' shoulder, okay? Because some of you just kind of want to just sit and just hope it comes, and it never does come, and so I'll help you along the way if you do have questions along the way. Okay? All right. The problem we're going to do is on page 311. All right? I'm not going to do much of the work. All I'm going to do is kind of show you the map. We're going to do problem number 1. It says laughing gas is sometimes used as an anesthetic in dentistry. It is produced when ammonium nitrate is decomposed according to the following reaction. We could make some laughing gas. I got some ammonium nitrate.
Can we? Will we?
I could. I guess.
Let's do it today.
Don't.
Don't? Okay.
I've had laughing gas before. It's not pleasant.
I bet.
Hey Carla, who should we use it on? She used it as escape.
I don't know.
Calm down.
Okay. So, our equation, again, this is something I like to do. The book doesn't show it. I don't care if you use it or not. I just think I've seen some benefit from some students seeing something in a way that makes sense, and I think it makes a lot of sense in which to kind of show where you're at and where you need to go. So, on this problem, in A it says how many grams of NH4NO3 are required to produce 33 grams of N2O. And so we're going to do part B. And so we know that we make 33.0 grams of laughing gas. Okay, and it's asking how many grams of water is also produced. So we want to get to here. Alright, so I'm going to give you N2O. No, I'm not going to give you that. So, it's because these are easy molar masses to figure out, and you guys need to realize you need to do that on your own. And those are two easy ones to do. So that's why this one's a good one to work with. So, that's where we're at. That's how many grams of N2O is produced. We can also figure out how many grams of H2O is produced by doing a mass-to-mass problem. Okay, so I'll come around as you guys have questions, and then I'll show this, show the work up here in case there's something you're missing along the way. And you guys are more than welcome if you check your answer with me and you want to continue on with the assignment. You can go ahead and continue on, and problem 173 and 175 on page 890 is the additional two problems that you need to do. All right?
But you wouldn't do it on the form.
So, I'll come around and check your answers to 1B.
Notice him?
That'd probably be the same case when you're gone. We won't notice.
You're really mean.
Well, you said that about Devin, didn't you?
Yeah, so.
So then you're not mean?
I'm like paying attention.
Okay. How's soccer going in, by the way? Good?
Oh yeah.
We're gonna run the mile today.
How long did it take you to run the mile?
12 minutes.
12?
15.
No way.
It didn't take
That's like walking. What's that? You don't know? He didn't yell the times out when you went by?
No, we run it today.
Oh, you run it today.
Yeah.
I will. I'll sit there with soft drinks
A soft drink.
in a
You're a
lounger.
hot dog right in front of us.
I could do that too. I could go down to what's the hot dog place in town now that they have?
Julie's hot dogs.
Yeah, I'll go to Julie Hot Dog Stand and get a hot dog.
Throw pops in the cart.
Okay, so guys, continue on working. For those who are finishing this one up, this is really a pretty easy one because the molar masses are pretty easy to figure out. Got to like those anytime that you can quickly figure out the molar mass and not have to worry. And I'll try to do problems where you don't have to do a whole lot of those type of calculations. Okay, so you got grams of N2O, and I think it's 44.02 grams to 1 mole of N2O. Then we do our mole ratio, so we're right here. And the next step is to go to moles of H2O. So for every 1 mole of N2O. You have 2 moles of water. So down here we put moles of H2O. Remember, we don't want to use 2 again, we just do it in the ratio. So for every 1 mole of water, you have 18.02 grams of H2O. Okay? And I think the answer is 27. 27 grams of H2O. Alright? So, 173 and 175 are those type of problems where you start out with a mass and end with a mass. 171 is that problem is going to give you a 171 is going to give you grams. You got to find moles. 69 and 70, you're given moles and you got to find grams. And 165, 167, you got to do a mole-to-mole ratio. Okay? Those are due. You need to hand those in Monday. If you get them done today, you want to hand them in, that would be fine as well. We'll do a lab on Monday.